Welcome to the Architect's Guide to Active Directory Inter-Site Replication. In today's enterprise environments, directory consistency across multiple locations is not just a technical necessity, it's the backbone of secure, efficient, and resilient IT infrastructure. This video is designed for architects and administrators who need to master the complexities of replication, from topology design to troubleshooting. We'll explore how replication ensures that every change, no matter where it originates, is reliably distributed across your entire forest. Let's dive into the engine that keeps your directory healthy and your users productive. Active Directory Replication isn't a one-size-fits-all process. There are two distinct models, intra-site and inter-site replication. Understanding this distinction is crucial for designing efficient and reliable directory services. Intra-site replication is optimized for speed, leveraging high-speed, reliable LAN connections to immediately propagate changes. In contrast, inter-site replication is engineered for efficiency and control, using scheduled, compressed, and cost-based mechanisms to conserve precious WAN bandwidth. This foundational difference shapes every aspect of your replication strategy. Let's start with intra-site replication, which operates within a single site, typically a local area network. Here, the assumptions are high speed, reliable, and low-cost bandwidth. As a result, changes are replicated immediately and without compression. This model is all about speed, ensuring that updates are quickly available to all domain controllers within the site. It's ideal for environments where network resources are abundant and latency is minimal, providing a seamless experience for users and administrators alike. Inter-site replication is a different beast. Here, bandwidth is limited, unreliable, or costly. To address these constraints, replication is scheduled, changes are compressed, and the process is cost-based. The goal is to conserve network resources while maintaining directory consistency. Every component of inter-site replication is designed with WAN efficiency in mind, from the way data is packaged to the timing of replication events. This model is essential for organizations with geographically dispersed sites connected by wide area networks. Sites in Active Directory are logical groupings of physical locations connected by high-speed networks. They define the boundaries where replication behavior shifts from the LAN model to the WAN model. Proper site design is foundational not just for replication, but for client service location and network efficiency. By mapping your physical infrastructure into logical sites, you enable AD to optimize both replication and client access, ensuring users always connect to the nearest resources. Subnets are IP address ranges meticulously mapped to specific site objects. This mapping is critical because it allows clients to locate the nearest domain controller and file server, optimizing logon and resource access. Accurate subnet configuration ensures that clients don't traverse slow WAN links unnecessarily. Misconfigured subnets are a leading cause of poor client experience, resulting in slow logons and file access, even when replication itself is healthy. Always verify your subnet mappings for a robust directory. Sites and subnets aren't just about replication, they're vital for client experience. The DC locator mechanism uses site information to direct clients to the nearest domain controller for authentication. Similarly, DFSN helps clients find the closest file server. When subnets are misconfigured, clients may cross WAN links unnecessarily, leading to delays. Ensuring accurate site and subnet mapping is a prerequisite for a healthy, responsive directory environment. A word of caution: misconfigured subnets are a primary cause of poor client experience. Even if replication is healthy, clients may experience slow logons and file access if they're forced to traverse WAN links to find a domain controller. Accurate subnet mapping is not just a technical detail, it's a prerequisite for a healthy, high-performing directory. Always double-check your site and subnet configurations to avoid these common pitfalls. Active Directory's replication topology is not static. It adapts dynamically as domain controllers are added or removed. The Knowledge Consistency Checker, KCC, acts as a local city planner, running on every DC to generate the intra-site replication topology. For inter-site replication, the Inter-Site Topology Generator, ISTG, manages the connections, designating bridgehead servers to consolidate replication traffic. This dynamic engine ensures efficient, resilient replication across your entire environment. Administrators have powerful levers to control replication: site links, cost, schedule, and interval. Site links represent the logical WAN connections between sites. By configuring the cost, you define the preferred path for replication. The schedule determines when replication is allowed, and the interval sets how frequently it occurs. Together, these settings shape the behavior of the automated KCC and ISTG engines, giving you direct influence over replication, efficiency, and reliability. Site link cost is about more than just bandwidth, it's about reliability. The KCC uses cost to calculate the least expensive path for synchronization. Lower cost is preferred, but it's wise to assign higher cost to unstable or failure-prone links, regardless of their speed. This ensures that replication relies on the most resilient paths, not just the fastest. Strategic cost assignment is a key tool for enforcing replication priorities and maintaining directory health. Microsoft recommends a formula for calculating relative site link cost based on available bandwidth. Cost equals 1024 divided by log, available bandwidth, in kbps. This formula helps you assign costs that reflect the true capacity and reliability of your WAN links. For example, a 64 kilobits per second link might have a cost of 567, while a high-speed 100 base T link could be set to around 100. Use these guidelines to ensure your topology favors the most appropriate paths for replication. Inter-site replication is optimized using data compression. Before data is sent over the WAN, it's compressed using the Express algorithm, a variant of LZ77 and Huffman coding, achieving about a 40% reduction in size. Modern domains use DFSR with remote differential compression, RDC, to transmit only changed file blocks. While compression saves bandwidth, it does add CPU overhead to bridgehead servers, a necessary trade-off for WAN efficiency. Several network ports are essential for Active Directory replication. DNS, port 53, is used for name resolution. Kerberos, port 88, for secure authentication. RPC endpoint mapper, port 135, for dynamic port binding. LDAP, port 389, for directory queries. SMB, divided by DFSR, port 445, for file replication, and dynamic RPC ports for the AD change payload. Ensuring these ports are open and properly configured is vital for healthy replication. By default, AD Replication uses a wide range of dynamic high ports, which can increase your network's attack surface. Administrators can improve security by forcing replication and netlogon traffic to use specific, static ports. This approach requires firewall rules to allow only the designated ports, reducing exposure. However, it introduces some administrative overhead, as changes require a DC restart and careful configuration. To lock down replication traffic, administrators must set static ports in the Windows registry. For NTDS, configure the TCP divided by IP port under HKLM, System, CCS, Services, NTDS, Parameters. For netlogon, set the DCTC pip port under HKLM, System, CCS, Services, netlogon, Parameters. This change requires a domain controller restart. While it reduces the attack surface, it does require careful planning and ongoing management. Replication in Active Directory is organized by directory partitions, also known as naming contexts. Each partition has a specific replication scope. The schema and configuration naming contexts replicate to every domain controller in the forest, while domain naming contexts replicate only within their respective domains. Application naming contexts have administrator-defined scopes. Understanding these boundaries is essential for designing efficient, scalable replication topologies. The Global Catalog, GC, is a special domain controller that holds a full, writable copy of its own domain naming context and a partial read-only replica of every other domain in the forest. This enables users and applications to search for objects across the entire forest without contacting every domain. GC placement is strategic. While it improves client access, it also increases replication traffic, especially across constrained WAN links. Every change to an attribute in the partial attribute set, PAS, must be replicated to every global catalog server in the forest. This creates a significant replication burden, especially over WAN links. When planning GC placement, balance the benefits of local GC access against the increased bandwidth consumption. Strategic placement is key to maintaining both performance and efficiency in multi-domain environments. Replication of forest-wide partitions, such as schema and configuration, depends on transitive trust relationships between domains. The secure channel, established by the net logon service, is used to verify trust paths and exchange security information. If this channel is broken, replication between domains fails, even if the network and topology are healthy. Always ensure that trust, relationships, and secure channels are intact for reliable replication. The integrity of the authentication layer is a prerequisite for successful replication. Replication relies on an authenticated RPC connection, which is established by the net logon service. This channel verifies trust paths and exchanges security information, such as SIDs, required for cross-domain authentication. If authentication fails, replication cannot proceed, regardless of network health. When trust or secure channel issues arise, the netem reset command is your primary remediation tool. It resynchronizes a domain controller's machine account password, effectively resetting and repairing the secure channel. This simple step can resolve many cross-domain replication failures caused by authentication problems. Replication failures are often symptoms of deeper infrastructure issues. A systematic, layered approach is essential for effective troubleshooting. Start with a forest-wide summary to identify problematic domain controllers. Then run comprehensive health checks, and finally zoom in on specific DCs to diagnose detailed errors. This structured process ensures that you address root causes, not just symptoms. It's important to understand that latency is not always a sign of failure. For example, a latency of 179 minutes on a link with a 180-minute replication interval is expected behavior. True failures occur when latency significantly exceeds the configured interval. Always compare observed latency to your scheduled intervals before concluding there's a problem. DNS resolution is the most common cause of replication issues. If a domain controller cannot resolve its partner's name to an IP address, replication cannot proceed. Confirm that SRV, CNAME, and A records are registered and resolvable. Use tools like DCDAG, Ping, NSLookup, and Tracert to verify name resolution and network connectivity between domain controllers. Kerberos authentication requires that the time between communicating partners is within 5 minutes. If time drift exceeds this window, authentication fails and replication stops. Check the current time source using W32.tm. And remember that the PDC emulator FSMO holder is the authoritative time source for the domain. Force a resync if needed to restore proper time alignment. Authentication errors like access denied or RPC server unavailable often point to secure channel or service principal name (SPN) issues. Duplicate or missing SPNs prevent proper authentication. Use DCDIAG to diagnose security errors and reset the secure channel with netdom reset if needed. Addressing these issues is critical for restoring healthy replication. Lingering objects occur when a domain controller has been offline longer than the forest's tombstone lifetime. Deleted objects remain on the isolated DC, causing inconsistency. Replication is halted to prevent reintroduction of deleted data. Confirm the issue with repadmin. Remove lingering objects, and only re-enable replication after cleanup is complete. To remediate lingering objects, first confirm the failure duration with repadmin. Then, use repadmin or the lingering object liquidator tool to remove the objects. Only restart replication after all lingering objects are purged. This process ensures that deleted data is not inadvertently reintroduced into the directory. A resilient replication topology starts with precision. Accurate site and subnet mapping is the foundation of a healthy directory. Prioritize client service location and ensure that your logical design matches your physical infrastructure. Precision in configuration prevents many common replication and client experience issues. Control the flow of replication by using site link cost as a strategic tool. Assign higher cost to unreliable links and manage schedules and intervals to align with business needs and network capacity. This approach ensures that replication is both reliable and efficient, supporting your organization's operational requirements. While the KCC and ISTG automate much of the replication topology, it's important to monitor their health. Watch for events like ID 1311, which can indicate topology stagnation. Regular verification ensures that automation continues to serve your organization's needs without introducing hidden risks. In firewalled environments, restrict RPC traffic to static ports to minimize the attack surface. This security measure reduces the risk of unauthorized access and helps maintain a robust, secure directory infrastructure. Always balance security with manageability when configuring your replication environment. Use site link cost, schedules, and intervals to intelligently control replication flow. Align these settings with your business needs and network capacity. Intelligent control ensures that replication supports both operational efficiency and reliability, adapting to changing conditions as your organization grows. Always resolve core dependencies first. DNS, time synchronization, and authentication. A structured, layered troubleshooting approach is paramount for diagnosing and resolving replication issues. By following a systematic process, you can quickly identify and address the root causes of failures. A robust replication topology is not an accident. It's the result of deliberate design, strategic control, and disciplined maintenance. By mastering the principles and tools discussed in this guide, you can build and maintain a resilient, efficient, and secure Active Directory environment that supports your organization's needs now and in the future. Let's clarify two core concepts. Intra-site replication occurs within a single site, optimized for speed and immediate change notification. Inter-site replication connects different sites, optimized for efficiency, using scheduled, compressed, and cost-based mechanisms. Understanding this distinction is fundamental to designing effective AD topologies. Sites are logical groupings of physical locations with high-speed connectivity. Subnets are IP ranges mapped to these sites, enabling clients to find the nearest resources. Proper configuration of sites and subnets is essential for both replication efficiency and optimal client experience. Bridgehead servers are designated domain controllers that consolidate all replication traffic entering or leaving a site. They prevent a mesh of redundant WAN connections, ensuring efficient and manageable replication across sites. Selecting appropriate bridgehead servers is a key architectural decision. Active Directory is divided into directory partitions, or naming contexts. These include the schema, configuration, domain, and application partitions. Each has its own replication scope, from forest-wide to domain-specific. Understanding these boundaries is crucial for effective replication management. The global catalog is a domain controller that stores a full copy of its own domain and a partial copy of all others. It enables forest-wide searches and is critical for logons and application queries in multi-domain environments. GC placement impacts both performance and replication traffic. The secure channel is an authenticated RPC connection established by the NetLogon service. It's used to verify trust paths and exchange security information required for cross-domain authentication. A healthy secure channel is essential for reliable replication between domains. The Knowledge Consistency Checker, KCC, is an automated process running on every domain controller. It generates and maintains the replication topology, adapting dynamically to changes in the environment. The KCC ensures that replication remains efficient and resilient as your directory evolves. The Inter-Site Topology Generator, ISTG, is responsible for managing the inter-site replication topology. It designates bridgehead servers and creates inbound connection objects from other sites. The ISTG ensures that inter-site replication is both efficient and manageable. In summary, mastering Active Directory Inter-Site Replication requires a deep understanding of topology, control mechanisms, and troubleshooting strategies. By designing with precision, controlling replication flow, securing pathways, and diagnosing issues systematically, you can ensure a resilient and efficient directory environment. Remember, robust replication is the result of deliberate design and disciplined maintenance. Thank you for joining this architectural masterclass. Apply these principles to build and maintain a directory that stands the test of time.